Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle. And so this was going to take some time. You'll know probably how long it takes me. Well, you will be because you'll be able to see the length of the video. But anyways, today's puzzle is called Inequalities, so this is going to take some time. It's probably at least an hour for you and me. And this is by Proxy 14. Let's get to the rules. We need to divide the grid into 9 regions that all consist of 9 orthogonally connected cells each. And we need to place the digits 1 through 9 in every row, column, and region once each. So this is typical chaos construction rule set. What is an orthogonally connected region? It means you can go from any cell in the region to any other cell in the region. That's too big. We could have something like this as an orthogonally connected region, as a 9-cell orthogonally connected region. It means you can go from any cell in the region to any other cell in the region just by going through edges while staying within the region. So this is an example of a valid orthogonally connected region. This is invalid as an orthogonally connected region because these two cells cannot connect to the rest, even though they can connect to each other by going through edges while staying within the region. They can't connect to the other cells in the region by just going through edges while staying within the region. They would have to go through a corner here or exit the region by going through an edge, neither of which is allowed for orthogonally connected regions. So that's an example of how orthogonally connected regions work. A cell's value equals its digit multiplied by the number of grid edges touched by its region. And digits inside of a cage can't repeat, and their values must sum to the indicated value. Okay, so, for example, this region touches 2 edges. 2 of the grid edges. There are 4 grid edges in total. 1 grid edge here, 1 grid edge here, 1 grid edge here, 1 grid edge here. So again, all of these regions are touching at least, or that's not true. You can touch 0 through 4. You can't really touch 4. If you try to touch 4, that's not going to be able to form a 9-cell orthogonally connected region, right? So you can touch 0 through 3 of the grid edges. And the number of edges that the region touches is multiplied by the digit. So for each cell, its value is equal to the digit that's in the cell multiplied by the number of edges the region the cell is in touches, number of grid edges the region touches. So, for example, this region touches 2 grid edges. So, the number of grid edges, how do you say this? The value of each cell in this region would have to be multiplied by 2 times the digit that's in the cell. That would occur for the entire region here, because that region touches 2 grid edges. So, again, digits in a cage cannot repeat, and their values must sum to the indicated sum. So the values of these digits the value of these cells must add up to 22 here. The value of these 2 cells must add up to 11, 30, etc., etc. So that is how cell values work. Cells that are separated by a black dot either have a region boundary between them, or the value of one of them is double the other, and 0, 0 is accepted. So 0 times 2 is obviously 0. So that's why you can have 0 and 0 be there. So either a region boundaries between them or the value of one of them is double the other. Can you have both is the question. I don't know. Interesting. I'm not sure if you can have both. You might or might not have that possibility. Yeah, I'm not sure about that. There might be a possibility that you could have both of that the case, but if it's not in a 1-to-2 ratio, you're guaranteed you have to have a region boundary between them. And if you don't have a region boundary between them, then it's guaranteed that one is double the other, which again, 0 and 0 works perfectly fine. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, the value of every digit in this cage is 0, obviously. So none of these cells here are in a region that touches a grid edge. Everything in the corners touch 2, at least. So there are at least times 2 for every digit in a corner cell. We have 49 here. And 42 here. Everything that's in the middle of the grid cannot ever be in a region that touches 3 cells. They have to touch at most 2 cells. Sorry, 2 edges. Because the only way to have a region that touches 3 cell edges, it has to be a straight line, and it touches essentially the top and the bottom and then the left edge, or it's here or it's here. That means it can never include any cell that's not already on the edge. So, to add up to 42, can we have 2 digits that are in a region that touches two edges, and then one that touches 1 is the question. I think so? Yeah, no, it's not possible. Because so you can't have repeats of digits in a cage. So the most you could have is 8 and 9 times 2. 8 plus 9 times 2, and then 7 as a singleton for 2 digits that touch 2 cells. Their region touches 2 edges, and then 1 touches 1. But that's 8 plus 9 is 17, times 2 is 34, plus 7, which is only 41. So all of these have to be in a region that touches 2 edges. Can they be in different regions? Maybe. So all of these are okay. What are the ones times 2? All the ones times 2 we're gonna mark with red, or times 3. This is 50. 7, 8, 9 is 24, times 2 is 48. So there has to be a 3-digit multiplication here. So 3-digit, we're going to do black. So this has to have a 3 here, guaranteed. So this is a region here that has to have touched 3 cells. Because to get to 50 and 49, it's not possible to only be 2 digits. or two times those digits, right? 789 is 24 times 2 is only 48. So all of these have to have 3 times something as a region, which means this is the region here. So we know this is definitely a boundary there. Okay, so these are all 3 times something. This is 3 times something. It could be 0 here. Can you have... So 3 times 8 and 9 is 17. Times 3 is 51. There is no way... So that there's no way that you can have this be part of a 0 region. So this must be part of a 1 times region. Because it can't reach... Technically, it could reach 2. So this is green or red. These are all blue. This... This is not a region boundary. So this must be in a 1 to 2 ratio. So we have 1 or 2 here. And this if this is 1, this is 2. If this is 2, this is 1 or 4. This is obviously at least touching 1 region. So this is green or red. Touches 3, touches 3, touches 3. This is touching at least 1. Times 3. Okay. Times 3, you have 6, 7, 8, 9, which is 30 at most. Times 3 is 90. So these have to add up to at least 9, which is 49 plus 50. We are guaranteed one of these digits is a 2. These must multiply by 3. So 8 times 3 is 24. So these add up to, at most, 7. So this cannot be... 7 times 3 is 21, which is less than the sum of this cage. So 7, which means this is 1 through 6. It can't be 2 here, because one of these is 2 to be in a 1 to 2 ratio. You could have 2 times 3, and then these are both regions that don't touch an edge. Or you could have 1 here. No, you can't have 1 here. If you have 1 here, that would be 3. So these two would have to add up to 3. Oh, I guess 1 could be 0, and then the other one could be a singleton. So that is possible. Never mind. So that is actually possible. This times 3, it could be 1 through 4 here. Cannot be 2 because of 2. To add up to 12, this is 4 at most. 4 times 3 is 12. We don't know about this. This could be up to 9. 23 is not divisible by 1 through... is not divisible by 3. So this must be non-0. So this is definitely 0. But there could be a boundary there. We don't know. One of these has to be... 1, 2... Can this ever be touching 2 cells? Or can this region ever touch 2 Oh, you could do that. So the answer is possibly, yeah. Hmm. Okay, so that's not restrictive. These must both be touching 2. Because 2 digits add up to... It cannot be... Oh, it could be 1 doubled. Hmm. You could have 1 doubled and then 1 touching 1 border. That's possible. Because 9 times 2 is 18. Oh, no. That's not possible. These both touch 2. So those both touch 2. Because 9 plus 8... Right. 9 doubled is 18 plus 8 is only 26. So they both must touch 2. Um... 27... 26. So this could be a singleton plus 2. 50. Well, the problem is we don't know if this is touching 2 or 1. This is either 0. Can you have a double? No. If you have a double, this cannot be 2. It would have to be 1, which times 3 is 3. And then doubling, these doubled, one of these doubled, or both of these doubled doesn't work, because we don't have 1 available here. So this is either blue or it's a singleton. So you could have 1. One of these is definitely blue. Because if you have 2 here, these are both blue. If you have 1 here, you have to be with 3 as a singleton, because you can't have 1 and 2 adding up as singletons. So one of them's guaranteed to be blue. One of these has to be a blue. Oh, this cannot be 1 and 2. So at least one of these is a blue. At least one of these is a blue. Technically, this could touch 2 edges. So we don't know if one of those is a blue. This guarantees that 2 of them are one. To form a region, this has to go either that way or it goes that way. Right? So at least 2 of these cells are touching. So this is obviously touching 2. This is touching 2. They can't get 3 because they are blocked from the third cell here. Technically, this could be 3. No, it can't. If we try to have this as 3 here, then this doesn't multiply to 3 as a 3. It doesn't have a sum times 3 equals 22, right? A digit sum is not... An integer times 3 is never going to add to 22. So this has to be 2 here. So this is 2, this is 2. One of these also is 2. At least. It could be all 3 of them are 2. But we don't know. 26. One of these could be singleton, the other one could be... One of them at least has to be 2. So we have 2 and maybe 1 there. You cannot have with a 0. So this is 2 definitely here. This is 2 or 1 here. So we cannot, obviously none of these can be 0. So these have to be green or red. This must be green or red because it can't be a 0 region like this. It can't orthogonally connect to a 0 region. So this still could be red. Okay. Touches 2. So this is 1 through 5 at most. Can you actually ever have 3? The answer is no. 3 doubled is 6, so 3 would have to be with 0. Or 3 as a singleton would have to be with 3. Can you actually have this both be doubled? Then. You could have a singleton with a double with 1 and doubled and 4. Can they both be doubled? Yes, 1 and 2. So that's possible. Huh. Oh, one of these is at least blue. Since one of these is at least blue, this has to exit out this way. So this is green or red. So this is the same one there. Because all of these are 0. Guaranteed. Hmm. Can this actually be doubled? I think the answer to that is no. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No. So this cannot be doubled ever. So this is guaranteed to be green, which means it must go to green there because there's no other place to go that will orthogonally connect. So this is guaranteed to be green. This cannot be 4 then. So this is 1 or 3 here. Okay. 23. To add up to 23, this could be doubled. And we can get doubled 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, we can't have this doubled. This also has to be green. Because it can't reach 2 edges of the grid. It can only reach 1. So then this must be... So these add up to a multiple of 3. So we could have 21 and 2 here. We could have 18 and 5, or 15 and 8 here to add up to 23. Interesting. Okay. This has to go out somewhere. At least. This could be boundary. Or it's a 1 to 2 ratio here. So at least 2 of these are going to have value. You could have 1, 2, and then 3 there. That is possible. You could have boundary there. Can these be 3 values? The answer is no. If we have 3 values here, The problem is it's 1, 2, 3 at minimum. That's 6. 6 times plus 3 or 6 plus 9 does not add up to 12. Even if we have 9, if we have 3 here. Oh, it could be 2, 3, 4. Never mind, that could actually work. 2, 3, 4 could work. 2, 3, 4 adds up to 9. 1 times 3 is 3, obviously. 9 plus 3 is 12. So it could be all 3. Ooh, okay. Never mind. What are the digits here? It has to be 6 or... It's times 2. So it's 21, which could be 4 through 9. So this is 4 through 9 here. Times 2. So they are... So this is part of a region touching 2. Are they the same region, then? I think so, right? Can these be different regions? Technically, yes. You could have something like that, and then something like that. Okay, never mind. So that's not a guarantee. Hmm. Interesting. This could obviously be two edges there. One of these is going to be blue. So we definitely have a blue here. One of these is either green or red. So 2 of these have to be blue. 2 of these are at least blue, and then the other one is green or red. We're not sure which. This is 4. One of these is obviously blue. How many are blue? You can only have 2 digits at most, so that means at least 3 of these are blue. 1427. This cannot be 9, because this is obviously touching one edge. So this is 8 at most. These add up to either 3, 6, some multiple of 3. Technically, this could still be blue, and this would be a singleton green. That is possible. Do we have anything from here? Probably not. We know this adds up to 135. Because it's 1 through 9 times 3. Which is 45 times 3, which is 135. This is 50 here. 99. So 50, 99. That's really restrictive. Isn't it? That feels really restrictive. 150. No, it's 1 4. So 50 plus 1 plus 99. 99 plus 6 is 105. So that's 155 here. 155 here. Plus 12. So this adds up to, at most, 12 plus 155, which is 167? Is that right? 155 plus 12 is 167. Yes. 167 minus 135 is 32. So we're missing at least 13 in this row. Hmm. Well, we could be missing technically a digit here or a digit here. That would be very strange. Actually, can we have a blue there? I don't think so, right? Well, maybe no. If we have a blue here, it has to orthogonally connect as a region to other blues. And then this would get blocked. Right? Because you have to go blue here to blue here. This doesn't exit out. So this cannot be blue, it's green. What about this? 1, 2, 3, 4, 5, 6, 7, 8, 9. That would block this. So this has to be green. Which means so this adds up to at most 32 here. Well, there's no way you can get to 32 without losing 2 digits in value. So this is green or red. Actually, I should put that's green or red also. Therefore, this cannot be 2 greens. It's 2 blues. So this is a 0 to 0 ratio, so they don't have to have a boundary. These are both 0, and that forces this to be a 2 here. 2 times 3 is 6. So this is not 2 here. This is 1 or 4. These must, so it's 32. 45 minus 32 at most is... Can this actually be red here? The problem is red has to be part of 2 regions. We have 1, 2... this can't go straight through. So if we try to go that red here, this has to eventually touch an edge. But it can't be 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait. That's 6 here. 7, 8, 9, 10. There we go. So that can't reach an edge there. It has to touch an edge somewhere here. So this can't be red, because that would block this from touching an edge at all. We can't obviously go that way for the same reason. So these are both blue. These are both blue. There doesn't have to be a region border there. So there is a region border guaranteed here and here. Same with this. Okay. This could go 1, 2, 3, 4, 5, 6, 7, 8, 9. So this can reach one edge here. That is possible. So this could potentially be red. Potentially. Unlikely, though. This would hold 1, 2, 3... Oh, I guess so. 1, 2, 3... 2, 3, 4, 5, 6, 7, 8, 9 does not touch 2 reds. So I don't think this can be red either. This has to be listing at least 13. So then this would be 4 through 9 there. There's no 2, obviously, there. Hmm. Okay. Um. Hmm. This is a 0 to 0 or 0 and 0 is a 1 to 2 ratio. 36. 4 unique digits. Yeah, you could have double. Actually, I think you have to have one of these be double, right? Yes, 4 unique digits cannot add up. So one of these at least has to be doubled. Or one of these has to be doubled. Mm -hmm. We have at most 2 doubled regions. Um, because we only have 3 edges. So only one region can touch 2 edges here, and one region can touch 2. Well, that's not true. You could have this touch 2 regions that way. Never mind. Never mind. Okay, that's incorrect. That is incorrect. This one of these could be blue. The other one either has to be a singleton, or they could both be singleton. Oh, they cannot both be singleton. This must because it cannot be 1 and 2 as a pair. So one of these is blue, and the other one is a singleton 3. So we have a guaranteed 3 here. Um, hmm, interesting. Does that tell us anything? I'm not really sure. Um, hmm. So we know there could be a region boundary here. We know in this region what happens if there's only 2 singleton in cells with the triplet cell. You could have 1, 2 here. That could work. Plus 3. Or this is 1. That's 3, so this could add up to 9. So technically we could have 1 through 8 here, because these could be 2 completely different regions. Right? We could have... Is that possible? I don't think so. Can these be 2 completely different regions? This, again, cannot get to... has to basically get to here to touch an edge. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cannot reach an edge there or reach an edge there. So it has to touch an edge here. The problem with this being a different region is if it touches an edge here, this is only 8 in size at most, if it's a different region. So these have to be the same region, which means this is a 1 to 2 ratio. So we have either 1, 2 here, or it could be 2, 4, with this being 3, and then we having 1 there. Or this could be 3, 6. So this is guaranteed to be a 1 to 2 ratio because there is no boundary here. This is the same region. Because as I said, if we have these are definitely the same region, because this has no other way to orthogonally connect out as a singular region. This, if we try to have this as a separate region, this must connect to an edge, so it does that there, and this is only 8 in size as a different region, so that doesn't work. So this must be the same region as that. And therefore it's a 1 to 2 ratio because there's no region boundary between them. This is 2 with 1 or 4. That because there's no region boundary there. This must add up to 15, so we have 6, 7, 8, 9 as possibilities there. Again, this adds up to 21. (26) can be either 13 times 2, so this is 4 through 9, or it could be 9 with 8 there. Okay, this cannot be 9 plus 8. If this is 9 and 8, that means 8 and 9 can't be here. To get to 21... Oh, wait, maybe that does work. Never mind. Yeah, you could have 9 there. Never mind. Okay. I was just thinking that, so that doesn't work there. 22. You cannot have a 1 here. Because 1 plus 9 is at most 10, times 2 is only 20. So we have 2 through 9 there. We've got at least 3 blues here in this box, in this cage. Hmm. This cannot be 8 and 9. Oh, this is equal to something multiplied by 3. So it's a multiple of 3. And then to add with this digit to add up to 50. Multiples of 3 are 48. So then this could be 2. What else? 48, which is 16. 45, which is 15, and 5, and 42, and which is 8, which is 14. So this is 14 at minimum. So that's 5 at minimum, 5 and 9, 6 and 8, could be 6, 5, 9, 6, 8, 6, 9, 7, 8, 7, 9, or no 8, 9 is possible. Interesting. What about this? Well, this could be doubled times 8 again. So you could have 1 here. So 48 plus 1 is 49. 45 plus 4, so this could be 4 or 2 doubled. Or this is 48, no, 42 and 7. Okay. Interesting. Hmm. So this is also 14 or higher. Interesting. Um, huh. Can this ever be 16? Obviously, it can't be 17. Can it actually ever be 16? So 7, 9, and yes, 7, 9, 6, 8. Yeah, so it could be 16 here. Obviously, 15 works also for both. So 5, 9, and can it be both 14? Yes. So if one is 16, the other one has to be 14. You could have both 14s there. So 5, 9, and 6, 8 could work. You cannot have 15. Can you have 14, 15? Yes. 5, 9, and 7, 8 also work. Uh, this is either blue or green. We don't know. Um, um, hmm. This again has to touch a single edge. And it cannot touch a single edge this way. So it has to touch a single edge here, which means this can't be double. If this is double, it has to be a different region, which would only be for whatever. It's very small in size. So this has to be part of this region also. So this is green. So this is all part of the same region. And it could just expand this way. So this could be part of another region here, which touches 2. So this can't be 2. This is 1, 4, or 7. Huh. Hmm. Well, this part is interesting. So we know these. Well, we don't know. You could have 14 and 14 here. That's 84. That would mean these add up to 15. Hmm. 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 Oh, wait. How? Okay, so what are the scenarios? 48 has to be, to get 48, you need 7 and 9 here. And then this would be 2. 45 would force 5 to be here, and it could still be 6, 9, or 7, 8. What about 8? 50 minus 8 is 40. Ugh. Anyways, 50 minus 8 is 42. 42 divided by 3 is 14. So it cannot be 6, 8. It would have to be 5, 9 there. Okay, what about 23 here? It could be 1, 4, and 8. This is guaranteed to have 1 or 3 here. Because this is at most 7. It could have both 1 and 4. It cannot have both 1 and 3 because this is guaranteed to be 1 or 3. But one of these is going to have to be 1 or 3 here. Because to get 2 unique digits, adding up to 7, it's going to have to be 1, 6, or 3, 4 at most. Or you could have 1, 4, or 1, 5. 4 can only be with 3 here. Or it could be with 1, I guess. So this is 1 or 3, which means this cannot be 1 or 3 here. Okay. So this could be 1, 3 as a pair here. Or 1 doubled with 2. So this has to be 1 through 4 at most. Because we know this region touches at least 1 edge. We don't have anything else, though. Okay. So again, you have to have 14 at least here. So that requires a guaranteed 8 or 9 here, and a guaranteed 8 or 9 here. This cannot be 8 or 9. What are the possibilities here? Okay, so if this is 4, I guess it could be with 1. Ugh. That's not too hopeful. Huh. Okay. What are the possibilities here? We have 3 here. That means this is blue, and this must be a 1-2 pair. Okay. That means this can't be 2 here. No 2 here. No 3 here. It's 1 guaranteed to be here. This is 5, 8 as a pair. That eliminates 5 and 8 in the rest of the row. No 1 here. So this cannot be 7 and 9. Still don't have really restrictions there. This cannot be 2, obviously. So we have to have a 3 here. That's interesting. And this is 4 or 7. This is 4 or 7. That leaves a 6 and 9 remaining here. So we're guaranteed a 3 here. This is 6 or... This doesn't have to be 4 and 7. Ugh. Okay. So it's 3 with 4, 6, 7, or 9. Oh. No, this has to be... Yes, this has to be 6 or 9 here. Because this is... 3 is a multiple of 3, obviously. This is a multiple of 3. And to add up to a sum that's a multiple of 3, the other digit has to be a multiple of 3. And 4 doubled or 7 doubled is not going to be a multiple of 3. And 4 single and 7 single is not going to be a multiple of 3. So it has to be 6, 9 here. 6 or 9 there. So what do these add up to? 23 minus 5. 23 minus 5 is 18, which is 6 tripled. So then this would be 1, 5. 23 minus 8 is 15, which would be 1, 4, which is 5 tripled. So this cannot be 6. It'd be 1, 5 or 1, 4. This is 14 or 15. This is 14 or 15 also. This would be 3, 6 is 9. That does not work. So this would have to be 3 and 9. Adding, so that would mean 9 cannot be here. 3 and 9 is 12. Wait, hold up. Never mind. No, okay. It cannot be 3, 6. Because 3, 6, 27 minus 9 is 18. 18 divided by 3 is 6. So that would have to be 3, 6, 6. Right, so that's right. So then this would cannot be 3, 9. 3, 6. It has to be 3, 9. That eliminates 9 here, so it's guaranteed to be 6 here. This has to be losing, so this would be 6, 7. So this would be 4 here. 3, 9 is 12. 27 minus 12 is 15 divided by 3 is 5. So this can't be 5. It's 1, 4 as a pair. 1, 4. These can't be 5 anymore. This can't be 5. That would force this to be 5 times 3, 15, plus 8 adds up to 23. That would force this to be 5. So all of this is looking kosher. This adds up to 15. That adds up to 15. So that's fine. Okay. Okay, that's not what I was hoping for. I was hoping for a contradiction. Okay, what happens if we have a 1 here? So if this is 1, this can't be 1. It could be either 2, 4 or 3, 6. What happens if it's 3, 6? That doesn't seem to work very well. What happens if it's 2, 4? That equals 6 plus 3, which makes this a 3 here. So we'd have to be 3 there. This is 2, 4. Again, no 2, no 2, no 1 here. This is 4. I think it's a contradiction. 4 and 3 add up to 7. Times 3 is 21, but we can't have a 2 here. So there's no way we can have 2 and 4 here. So this cannot be a 2, 4 pair. So if this is 1, it has to be 3, 6, and then this is blue no matter what. So this is always blue. Interesting. So what happens if this is 1? We have 1, this is 4, 3, that's 2. So no 1, 2 there. It's 3, 6, no 2 there. No 4 here. It's 5, 6, or 7. 3, 6 eliminates 3, 6 here. This could still be 1. So this is... So either way, there's guaranteed 4 here. Interesting. So this is either 1, 4, and 8, or 3, 4, and 2. Okay, well that's good to know. So either this is 1, 2, and that's... If this is 3, this has to be 1, 2. Or if this is 1, this has to be 3, 6. That's 9, plus 1 tripled is 3, that's 12. So then this is guaranteed to be at least 13. Technically, this could be doubled. This can never be 5 then. So this is guaranteed to have a 4 here. So we have a guaranteed 4 here, and this cannot be 5 or 6. It's 1, 4, or it's 3, 4 here. So no 4 there either way. So then this adds up to 5 or 7. So this cannot... That's 5 doubled. It's 15 plus 8. 7 doubled, or tripled, sorry. 5 tripled is 15 plus 8 is 23. 7 tripled is 21 plus 2. So this cannot be 5 there. Okay. This technically could be doubled. So... all the same set here. Or same region here. We have a 1, 3, 4. One of these is 8 and 9. One of these is 8 and 9. So we have 5, 6, 7 there. We are guaranteed... If this is 3, this is 1, 2. If this is 1, this becomes 3, 4, and then that's 2. So there are no more 2s possible in row 8. So should we go through what happens if this is 3, 6? I don't know. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. And we know we have one of these is 0. So there's at least 2 regions that do not touch the edge of the grid. There could be more. This is 1 to 2 ratio. 2 ratio. Okay, so what happens again? If this is 1, this is 3, 4. That's 2 there. This is 3, 6 as a pair. No more 6 there. Can we ever have a 1 here? Maybe? If we have 1 here, this becomes 7, 9. 16 times 3 plus 1 is 49. No 7, 9 here. No 7 here, it's 5 or 6. Hmm. That doesn't seem to be very restrictive. That kind of sucks. Anyways. What happens if 1 is here? That means obviously this can't be 1. Technically, you could have doubles there. You could have technically... Hold up. I don't know. That seems... This has to be with a with non-multiple of 3. One doubled. Oh. I just don't know if assuming that is doubled seems ugh. Okay, assuming it's not doubled. This has to be 5 or 8. Okay, so 1 5. So 1 having been there. 1 5 1 8 is 9, so that's 6. 1 5 is there, so then this would be 7. So one of these would have to be 5 and 9. That eliminates 5 and 8 here. So it could be 4 9 or 7 9 here. Either of those works fine. So unfortunately, that doesn't help. No real restrictions there. 2 and 3 cannot be here. So this must be 1 4 5 6 7 8 9. That's interesting. That's the same for the whole column. At column 6. Because we're guaranteed a 3 here. And it's a singleton. But it could be any singleton here. What else are we looking for? I don't know. 11, 42, 30, 36. Yeah, the problem is we could have multiple regions which touch 2 edges. I was thinking that they were limited to 2, but we could actually have 3 or 4. Interesting. Okay, we can have 4 regions that have that touch 2 edges, then at most. Interesting. Okay, if this can, one of these at least has to be a green. Because even if this can't be a singleton by itself and then add up to 11, and if it's a double, it has to have an odd digit here to add up to 11. So at least one of these is a singleton, but we don't know which. And we don't know if it's both or whatever, right? We know at least 3 of these are zeros. 2 of these are zeros. What else do we have? We have a guaranteed 1 or 3 here, so this cannot be 1 or 3. We have 2, 4, 5, 6, 7, 8, 9 as possibilities. Hmm. That's the problem. I don't know where else to go for the restrictions. Um, 36, 18. At least 2 are doubled there. But that's not that restrictive. We have some blue here. 3 blue. So no, that's too unfortunately that's if we just signify the 3, that's going to be very how do you say it? It's going to be misleading. To me at least. So huh. What happens if we add up these? That might be useful. What is the sum of all those? Maybe that's where we can go. Or we can add all these up. That's interesting too. We know we can't have a 3 there, but there's a lot of doubles. Or there's potentially a lot of doubles. This seems more promising since this is really restrictive. Okay, let's just do these. That's interesting. 11 plus 6 plus 14 plus 18. 11 plus 6 plus 14 plus 18. That's 20 plus 11. +20 plus 11. $31 plus 18 is 49. Keep that in mind. I'm going to go to the bathroom right now. I'll be right back. Okay, I'm back. Let's continue. So again, we had 49 here. We have... This is guaranteed to be a single at least. This is guaranteed to be a single at least. Sorry, this is guaranteed to have a single. This is guaranteed to be at least a single. So that's 2 plus 1 and 2 possibly in this for this cage is part of the 49. So 49 minus 3 is 46 at most. 46 divided by 2 is 23. So the first 6 digits could be doubled to add up to 23. But you cannot have 7 digits doubled. So this cannot be red here. This is guaranteed to be green. Does that help? Not really. Interesting. So what's interesting is if 3 of these are doubled, then this must add up to 9. That could work. Hmm. We do have all of these digits summed up. And then we could add one more there. Maybe that's what we should focus on. I need a calculator. This is just way too much possibility for messing things up. Okay. Let's add columns 7 through 9 up then. 22 plus 10 plus 26 plus 30 plus 18 plus 4 plus 19 plus 10 plus 14 plus 27 plus 23 is 203. Okay. I don't know if that's helpful. What about just columns, all the digits? Oh, that's interesting. This is very restrictive. Huh, let's try that. 30 plus 18 plus 10 plus 23 is 81. We know 15 is doubled here. So this is guaranteed 15. This is a singleton. um... We are adding 2 digits and subtracting 1 digit from that. This could be red. Either this is 2 greens or one of them is a red. So you could still have a blue there. Is that helpful? I don't know. What about all of these? Maybe this will be helpful. Let's calculate that. We have 22. 22 plus 10 plus 26 plus 4 plus 19 plus 14 plus 27. That's 122. We could have 7 tripled, so that subtracts out 14 potentially. So that's 108. We have 2 at least going to be doubled. So we could subtract out 22. And then add back 11. Oh, we would have to add back... No, we already subtracted out 14. So there must be some other doubled. I don't know if this is helpful. Okay, what about top 3 rows or top. Hold up. What about these sets here? Now that's interesting. You have one of these is a singleton. They cannot both be doubles. One of them is guaranteed to be a singleton here. Because it's 11 for 2 digits. So you could have a double. Can you have green, red? You could potentially if this is green. How does that work? So say this was green and this was red. So if we have that red, that has to be green. Okay, that's interesting. So if this is... Okay, so we're making this red, so therefore this is green. Green has to go out and cannot touch another region, another edge. So it would have to be at most this way. But this then cannot... 1, 2, 3, 4, 5, 6, 7, 8. Oh, you could touch 2 edges there. Dang it! So you could do something like that. I thought I thought... Well, that kind of sucks. Wait, why can't this be red? 1, 2, 3, 4, 5, 6, 7. Ah. Hold up. I don't think that works. No, it could work. It doesn't have to go this way. So it does have to go out this way. This has to touch 2 regions. But it could just do something like this, right? And then this is a region here. Can this touch a single region, though, here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No. And the problem is this would have to form a red. So that would block this from touching a region. Oh, unless this isn't red. Never mind, it could just do like that. And then red. Okay. Oh, or some combination therein, right? So it doesn't have to be all... Okay, so that could work. Not liking that. Dang it! Ugh, okay. Okay, let's maybe still add and see what these are. Calculator, okay. 18 plus 36 plus 11 plus 22. That's 69. This is not helpful. That doesn't really tell us anything. Maybe add these? I don't know. Hmm. This could be green and red. That would just be 1 doubled plus 2. It could be 1 doubled plus 2 single. Or 1, 3 as a pair. Or it could be 4 with a 0. This is good. This could go a lot of ways. Can this actually be 0 here? Yeah, you could have a double here of 9. You could go 0 that way. And this would be a double of 9. Or 0 this way. And then this is a double of 9. 4, 5, 6, 7, 8, 9. Yeah. This is either a double or these are both green. Can these both be double? 1, 2, yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. That is certainly possible. There's just so many or not restrictions, so many possibilities. Uh, so we have 2 here, blues 3. That's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So no other necessarily restrictions. Okay, what happens if this is... What happens if this is 5, 9? Okay, let's just try various things. 5, 9, that forces this to be 8. That works fine. 14 times 3 is 42 plus 8. That makes this 2. So this must be 3 and 4. That means no 2 here, so no 1, 2. It's 3, 6 as a pair. That makes this 1. No 5, 9 here. No 6 or 8 here. No 5 here. It's 6 or 7. This is 8 here. 6 and 8 is 14. Plus times 3 is 42. Plus 7. 7, 8 is 15. Times 3 is 45 plus 4. So this would not be, this would be 4 or 7. We would guarantee a 1 here. Technically, this could be doubled. That's not helpful. Does this help? I don't think so. No, not really. What? Okay, so let us try this. Okay, if this is red, this can't be red, it's green. Green has to orthogonally connect out. This is definitely going to be red. Red, this has to be green here. This has to be red. This must be red that way. This then has to be a 1-2 pair. Okay. And the double has to be 1. The single has to be 2. So this is 1, that's 2. So no 1 here. This can't be 1 or 2, so this has to be blue. So we have to have a 1 or 2 here to add up to 2. No 2 here. Okay, so how does this work? 26 with 1 doubled. 9 times 2 is 18 plus 8. So this would have to be 9 and 8. So no 8 or 9 here. This can't be 8 or 9. This can't be 6 or 7. No 8 and 9 here. No 8 or 9 here. To add up to 21, we are guaranteed an 8 or 9. This cannot be 4, 8, and 9 adding up, so that's not 4. We have to have 5. 5, 7, 9 adds up to 21. 5, 6, and nothing else adds up to 21 there. So this is 5, 7, that's 9, which means this can't be 9. That's 8. To add up to 17 is 7. This is not possible. So we have 2 7s in row 3. Therefore, this is not possible. So we cannot have... Okay. So this cannot be red here. This is guaranteed to be green. So this is guaranteed to be green. On top of that, these can't be a red-green pair, because that leads to the contradiction that we had here. So these must be touching 2 reds. Can any of these be just touching a single? I don't think so. So then these have to be touching 2 reds. Two edges, sorry. And they must be red. Right? If we try to have green here, this has to go out green that way. I guess it could be... Okay, this has to be... If we try to have this as green, that doesn't work. Because it has to go out green as a region, and then this doesn't form a region. So this is definitely red here. But this could be green technically going out that way. I don't know. 1, 2... Oh, yeah, this is already touches 2. So that's fine. Interesting. So this is double, which means it has to be 1 through 4 there. Huh. This is guaranteed to be green. This cannot go out this way and touch a double that... Touch an edge here and then an edge here. So I think all of this is part of the same region here. I mean, well, no. You could have... Yeah, you could... Never mind. You could do something like that. That's 5, 6, 7, 8. Yes, you could do something like that. Never mind. It's not guaranteed that this is the same region. Oh boy. But you still could have this be part of the same region. 26 is 13. Divided by 2. 13 plus 15 is totally possible. In the same region. Okay. So this digit is, if this is both double, then this is 1 through 4. If this is single, it could go up to 8. That's quite high. We know there's a guaranteed singleton here. Right? You can't have all of these be doubled. But the thing is, the singleton could do something funky like that. So we know there's a singleton here. Can it 1, 2, 3, 4, 5, 6, 7, 8? That is possible. Unlikely. Hmm. You could have all of these be a double. No, you can't. Can this be a 1, 2, 3, 4, 5, 6, 7, 8, 9? So this cannot be a double of with this part. We're trying. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. We're trying to give this part 9 possibility. So the only way this can be part of a double is it has to be part of a double there. 1, 2, 3, 4, 5, 6. And that would block this from being a... Well, no, it could be doubled that way. No, you can't. 1, 2, 3, 4, 5... No, okay. This cannot go double be part of there. And if we have double there, if we have double here, what part is touching two edges? Obviously, you're touching this edge. You have to get to here. So therefore, this or this would be part of that double. But the problem with this being part of the double is you block this from forming a region. So assume this is not part of that region. Then this is not going to be able to... So assume this is not part of the region here if this is doubled. Then it can only go that way, and then this is not large enough as a region. So this must be part of that region as a double, but if that's part of the region as a double, this can never touch two edges, right? Because it'd be 1, 2, 3, this is double. So this, if we try to go around here, that would force this to be 4 at most as a side. 1, 2, 3, hold up. 1, 2, 1, 2, 3, 1, 2, 3. We can't go this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. That gives us only 1, 2, 3, 4, 5, 6, 7, 8 as a possible region, which is too small. So this then cannot be part of the double here, because for this to be doubled, it has to block this from being part of a valid region. So this is not double, which means we know this adds up to 13 exactly, because the sum of this plus a triplet of that, again, so 49 plus 12 plus 50 plus 6 plus 23 plus 27 minus 45 times 3 is 32. And 45 minus 32 is 13. So this is guaranteed to be 13 here. It cannot be 5 and 8 because we have a guaranteed, if that's 5, 8 as a pair, adding up to 13, which is the missing 13 in row 8, that would eliminate all possibilities for this cell. So we know this is either 4, 9 or 6, 7. We're not sure which. Okay. That's kind of convoluted, but good to know. So then this is either 3 with 6 or 9. It can't be 3 with 6. It's 3 with 9. Because if we had 3, 6 here, that's 9. 27 minus 9 is 18 divided by 3 would be another 6 here, and we can't have repeats in the cage. Or... I don't know what the other one is. We can't have 2. We can't have 6 at all. So if this were 3 and 6, this would have to be 4 and 9. So we know 1 out of 1 or 7 would be here. And then that's a 1 mod 3. We need a 2 mod 3 to add up to, so that this is multiple, this sum is a multiple of 3. So then we'd have 2, 5, can't have 2, it'd have to be 5 or 8 here. Okay. That's kind of convoluted, but okay. um... Can we have a double here? I think we have the same problem, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's too large. And if so, we assume again that this is not part of the same region as this. So it would have to go 1, 2, 3, 4, 5, 6, 7, 8. Oh, that could work. 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, that could work. And then these are touching 2, and this is touching 2. So that could work. This is just too far. Interesting. This either has a single digit touching 2, or it could be 2 digits, 2 singletons adding up to 10. Or it could be a doubleton with a singleton, or 2 doubles. So all of these still are in play. 18 could just be a singleton touching 2. We need at least one singleton here, but it could just do something like that. So that's fine. Can this be a double? We know we need a singleton here to add up to 19. But if we had double going that way, or... we can't have double connecting this way, because the problem is then all of these would also be double. Well... Yeah, because we'd have to touch this edge, we'd have to touch this edge, and then we can't have 2 regions between. So it'd have, yeah. So then it would have to go this way. 1, 2, 3, 4, 5, 6, 7, 8 would block this from touching 2 cells, because that would have to go that way and get blocked. 1, 2... Wait. Oh yeah, we can't have a 1 there. Again, we're missing 13 there. At least. So can we go 1, 2, 3, 4, 5, 6... 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's too big. So this can't be red. It's definitely green. Because we need a green somewhere here. At least one. We could go red here again. 1, 2, 3. No. Oh, we can't go red here. If this is red, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 as a red. That could work with this being 9, but the problem is this then doesn't have any green cells, which we need. So this has to be a green. Okay. So this is either 5, 9, or 6, 8. Okay, that's good to know. We need a green here. That's valid now because this could be just double reds. So that's fine. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. That could work. Okay. So this adds up to 13. Doubled. This adds up to 15 doubled. 21 doubled. Jeez. Convoluted. I think this... One, two, three, four, five, six, seven, 8, 9. Can we have two regions here which are touching both edges? This has... So this is saying this is part of a different region. I think the answer is no. So say we have a 9 cell here. Obviously, this has to touch somewhere before this 1 cell. It can't go like that, because then this is not going to ever be a large enough region. So it has to touch either here or here. And this is gives us the most space. And then this becomes a 9 cell region at best. 1, 2, 3. And the problem is we would have to go this way to touch both edges. But these will all be red in that case, and therefore doubled and can't add up to 19. So this cannot be a separate region. This must be the same region as this. Which means this can't be 6 and 7. It has to be 4, 9, or 5, 8. Because if 6, 7, that would eliminate all possibilities for the cells in this region. So this is the same region. That's a 2 times region. Therefore, we have an 8, 9 guaranteed here, 8, 9 guaranteed here. This cannot be 8 or 9. That's interesting. So we could go 3 that way. We could go 3 that way. So we can go at most 3 this way, at most 3 this way. So any of these could be that dark region. Okay. I don't think we can really go 3 that way. If we go 3 this way, we could still have a... No, we can't have a red region here because that would block this as a green region. So this is so we can only have doubles if we go going this way, if it's part of this region. So can this ever be doubled here? I think the answer to that is no. If we try to go double this way, all 3 of these cells have to be part of a singular region. This is 0, but you could have a 0 there, technically. So double, double, double. And how many... This could be 0. How many cells do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 cells which are not part of that region and can't form two full regions here. And this would block off these regions from, and you could have 10, 11, or 12 in these cells, but they're not going to be able to form complete regions. So this can never be doubled. So this has to be then, none of these can be doubled. So therefore this has to be two valid cells. So it cannot be 2, 8 because of the 2, 8 in the, that would eliminate all possibilities for that cell. So this must be 1, 9, 3, 7, or 4, 6 here. Okay. We don't know if this is part of the same region. It could be. It could be part of some other region going this way. We don't know. We could have a double here. That is perfectly fine. Okay. We could have doubles here. That's fine also. This could be even 0, though. As I said, we could have 0 going here and then just a double 9 there. Okay. Ugh. We know one of these is green. We don't know which. This is a double. This can't be 5 or 7. 5 plus 5 doubled is 10. Yeah, and then yeah. And if this is 5 or 7 as a single, that with a double doesn't work. Oh boy. This is a doozy. This is definitely very hard. Very interesting though, but very hard. Okay, we could have a boundary here. Could have a boundary here. Otherwise, this is a 1 to 2 ratio. So can this actually be a double? Well, you could have a double technically go that way. And then this would be blue as a singleton. Can this be double? Well, we could technically have two doubles here. That is possible. Okay. Interesting. Okay, so maybe we add the sum again. We know this is double. We know these are single. Hmm. um. Hmm. Um. Hold up. What is this if it's 1 and 5? Then that could be 7. Okay, that could work. Never mind. 5 and 7 is 12. And that would have to be 5 there, so that doesn't work. What about 7 and 8? So this could be 7. So we can have 1, 5 here. That works. 1, 5 is 6. 21. 7 minus 6 is 21. Divided by 3 is 7. So that works. We could have 1, 8, and then 6 here. Does that work? Okay, let's... So we tried all the 3 9s, so that's fine. So now let's try all the other possibilities. 1, 5 works. That forces this to be 8. We have 2 here. This must be 3 and 4. That makes this not 1 or 2. It's 3, 6. That means this can't be 6 or 7. It's 4, 9. So this can't be 1 or 4. It's 7. 15 minus 8 means this can't be 7. It can't be 6, 8. It's 5, 9. Must be 7 here. And this is 6 and 8. And that works fine. Okay. So 1, 5 works. What about 1, 8? 1, 8 means this is not 8. It's 5. That's 2. So again, this is 4, 3. That makes this 1. Hold up. Did 1, 5 work? 1, 5, not 1, 2. It's 3, 6. Which makes that 4, 9. This is 8, 2. This is 4 and 3. Oh, I think I had that as right. Yeah, that works. Okay. What about 1, 8? Makes that 2. Again, 4, 3. This becomes 5. So 1, 8 is 9, which makes that a 6. Times 3 is 18 plus 9. 5, no 1, 2. It's 3, 6. No 6, 7. It's 4, 9. Therefore, this becomes 7. 5. That means this adds up to 15. So this is 7, 8. No 6, no 7, 8. 5, 9 is 14 times 3 is 42 plus 7 is 40. So that works also. So 1, 5 and 1, 8 work. What about if this is 7? I don't think that works. If this is 7, that means this can't be 6, 7. It's 4, 9. So if we have 7 here instead of the 1, we have 7 here. This can't be 7. This can't be 6, 7. It's 4, 9. So no 4 there. 7 eliminates 7 there, so it's 1. This is obviously not 1, 2. It's 3, 6. That makes this 1. So this is 4, 3. That's 2. And this could be... So this is 1. That makes this 7, 9. So 49 minus 1 is 48. Divided by 3 is 16. No 7, 9 here. It's guaranteed to be 8 to have here, so this can't be 8. It's 5. That means this is 6, 8. This would be 7, 8 there. 15. 27 minus 15. Which is 12 divided by 3. No, so this cannot be 7. Okay. So this is then, if this is 1, 2, what do these become? This is 1, 2, this is 8, that's 5. This has to be 3 and 9, which makes this 6, 7. So 1, 2, 8, 5. This is 3, 9, and 5 here. So that's that possibility. 1, 2, 6, 7. This is 8. This is 5. That leaves this as a 4. Otherwise, this would be 1. This is 3, 6. That makes us 4, 9. This has to be 1. This has to be 7. And this would have to be 2 in that instance because this is 3, 6, 1. That's 3, 4, and 2. So this could still be 1, 5, and 7. And 1, 8, and 6. So those could both work. Dang it. I was hoping that would not. Okay. Well, anyways. So this cannot be 7 and 9 here. Can this be 7 and 8? Can this ever be 7 then, if that's the case? If we have 7 and 9 here, we can't have 7 and 9 anymore. Can this be 7 and 8? If this is 7 and 8, I don't think we can, actually. That forces this to be 4, obviously. So no 4, 9 here. It's 6, 7. No 3, 6 there. It's 1, 2. That means this be 3, 9, and 5. 1, 2 makes that not 1. It's 3. No 7, 8. 2 eliminates 2 there, so it's 8. That's 5. This cannot be 5. Ah, that could work. Yeah, never mind. Okay, so it could be 7. Oh. Too many possibilities. Okay. This can never be 2. Because if this were 2, even if it's doubled, that's 2 plus 7 doubled, which is 18. Same with this can't be 3 either. Oh, that's interesting. So, if these are doubled, they must be part of this region. What does this add up to right now? So 22 plus 10 plus 26 plus 30. That's 88. Which would require a 1. So that actually could be doubled. Dang it. Ah! Okay. Would that work, though? Okay, so we don't have 8, 9 available if both of these are doubled. Because they would be part of this region. So this could not be, actually. Oh, this can't be 8, 9. Doubled. So can this actually ever be a singleton? Yes, if this is 7. 14 plus 8. So that could be. Ugh, okay, never mind. Yeah. I'm just trying. Yeah, this is a struggle, definitely. This is pretty difficult. Hmm. This can't be 4. If this is 4, that would force both of these to be 8 and 9, which would eliminate all possibilities here. Uh, hmm. This is pretty difficult. Can this be double going this way? 1, 2, 3, 4, 5, 6, 7, 8, 9. Probably not going that. Oh. If we obviously can't go this way through that. We can't go that way either. I guess technically we could do that. Then this would need to be in a 1-to-2 ratio as a double, which is possible still. Can these all be double? That's 32, 16. Yes, it's possible. Unlikely, but still possible. Wait, is it? Minimum here for these 4 digits. If they were all doubled, we cannot have 2 or 4. It would have to be either 1, 2, 2, 4, 1, 2, 1, 5, or 2, 4 as digits. So, can we have 3, 4, 5, 6? That's 18 times 2. That's 36 already, which is greater than 32. So we can't have 3, 4, 5, 6 as a double. So if this is double, there's no way everything in between has to also be doubled because they will be guaranteed to be touching 2 edges. Because this has to touch 2 edges. It cannot go through here. It has to go something like this. It can't even do that. So it would have to do that. One, 2, 3, 4, 5, 6, 7, 8, 9. And that would not be valid. Okay, so that's not valid because this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Or 7, 8 only cells. So again, we can't go twice through the 4 cage for the doubled value. And we can go only once here. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's too small of a region. I guess we could technically go that way. 4, 5, 6, 7, 8, 9. No, that doesn't work either. Because this is, again, size 8 as a region. So, I don't think this can be doubled. This might still be. 1, 2, 3, 4, 5, 6, 7, 8, 9 is possible. So this cannot be doubled. It's a singleton there. But this doubled. So can we do it without entering the 2? Because if we're entering the 2 as a double, it's going to be 1 that's doubled. And this would have to be 1 that's doubled if that's the case. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That would mean the space is 8 at most. So the answer is no, this cannot be doubled. So this can't be doubled, which means this is 1, 5 or 2, 4 here. That means the minimum here can be 1, 3, 5, 6, or 2, 4. 2, 3, 4, 6. So 1, 3, 5, 6 is 1, 3, 5, 6. 1, 3, 6. 1, 3, 5, 6 is 30. Or 1, 3, 5, 6 is 15 times 2 is 30. We could have a blue here, technically. So then this could be green, and we could have red there. So all of these still could be red. Oh, wait, but this could... Huh. This could technically still be part of this region. Is that possible? I don't think so. So assume these two are part of this region. Then this is doubled. This is doubled. That's 1 through 6 doubled, which would be 21. 1 through 6 at minimum doubled. So that's 21 times 2, which is 42 at minimum. But these add up to 38, which is too small for it to contain the sum. So this is obviously not doubled. What about this? 1 through 5. Well, it couldn't be 1 through 5, because if this is... Okay, if this is doubled, it has to be 1 doubled with 4. So this would be at minimum. So let's try. We have 1, 4 there. So that's 2. This would obviously have to be 2. What is this? 1, 2, 3, 5, 6. So this is 2, 3, 5, 6. That is already 32. 2, 3, 5, 6 adds up. 2 and 6 is 8. 3 and 5 is 8. That's 16 times 2 is 32. And this is guaranteed to be some sort of value. So that's too big. Therefore, this one also cannot be read. So we know this is a 1, 5 or 2, 4 pair. Okay, that's good. That was kind of crazy to get through there. Anyways, we could still have multiple okay. I think this has to be part of this region. Well, maybe not. We could have 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, we could still have 2 regions. Never mind. Actually, it would have to be 1, 2, 3, 4, 5, 6, 7, 8. And actually, that is not possible. That is not possible. Because the reason why, we have 8 here. We cannot enter any more of cage, the 2 cage and the 4 cage, to get doubles, because we already have, like, you can't have 2 doubles adding up to 2 or 2 doubles adding up to 4. That's just not possible. You have 1 and 2 at minimum, which adds up to 3 times 2 is 6. So we can't enter those cages. This we've already shown doesn't work because we have to have a 1 there. for this to work. And we need another cell in this region. Can't be in the cage here. Can't be going this way. Can't be here because this has to be a singleton. The only space we have left is here. But then that blocks this from being a full region. So these cannot be part of some other region. They have to be part of this region here. So we know this as a double. These have to be the same region and as a double. That's interesting. Wow. This is really hairy. This is definitely a very hard puzzle. Um, hmm. Okay. Okay. Um, hmm. It is pretty convoluted. One of these has to be green. This can't be red here. None of these can be red. They have to go through one of these, and you can't, or both of these, which obviously can't both be red, to get the red. So none of these are red. Any of these could be green. Red could be here or here. This is not a region border. We already knew that. Um, I think the black dots are going to have to not be a has to be an either or. It cannot be both, I don't think. Because if it were both, I don't think there's a way you can really differentiate these. That's just my thought process there. Um, hmm. Can this actually be doubled? If this is doubled, it's part of this region here. And it would have to be 2. You could have a 4 here. 4, 8, and 9. That actually is potentially valid. Hmm. Hmm. Man, this is rough. Hmm. So we have 5 guaranteed doubles here. We have 4 more that we can attach to. Be 5 there, 5 there. So, okay. What happens if all of these are double? Then we have 1, 3, 5, 6 or 2, 3, 4, 6 as minimums for the doubling value. Okay. 1 plus 3 plus 5 plus 6 is 15 times 2 is 30. So this would have to be 2. This would have to be 2. It could be doubled. So it could also be 1 there. Whoa. And then this would have to be a blue, which is possible. Okay, so we have 1 through 6. That would be 30. This would be 1 or 2. This would be 1 through 6, so that would force this to be 7. We'd have 1 or 2 there. This would have to be 8 or 9. 8 or 9 here. That would mean no 6 or 7 there. It's 4 or 9. No 9 here. No 8 or 9 here, obviously. This would have to have 3 and 6 here. So no 6 in this pair. That seems fine. I was hoping it would lead to a contradiction. So, no. This could still be 2 greens and 1, 2. That is certainly possible. Interesting. Okay. I just thought of something here. So this has to be some part of a region. Can it be different than this region here? So we have 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is no, that is not possible. Because we know this is a double, so it has to be part of this region. And if this is a separate region, this would have to go all the way up to here. We'd have 1, 2, 3, 4, 5, 6, 7. We could, I guess we could do 8, 9 there. Okay, so that might work. Or 8, 9. Ooh, okay, so maybe that works. No, it doesn't work. Okay, well, either way, if this is not part of this region here, obviously can't go to the zeros, but we go 1, 2, 3, 4, 5, 6, 7, 8. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. So could do that, but the problem is this becomes 1, 3 as a pair to add up to 4. And this requires 1 or 3 in this region. Here. So that would be a contradiction. We'd have a repeat in that region. What happens if we don't include, we only include 1 here? It has to go this way if this is not part of that region. Which means... So it has to go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a part of a separate region. So the problem with that is that this cannot go this way, because then this would be touching 2 regions. But we know this can't be touching 2 regions, because this must also be... well, we have all sorts of problems with that. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? We tried, I think, this, and that didn't work either. Right, because of the way that specifically had to be. This had to be 1 doubled with 4, I believe. And then this would be 2, 3, 4, 5, 6. 2, 3, 5, 6. And 2, 3, 5, 6 would be... Why was this not working? I don't know. 2, 3, 5, 6. 2, that's 16. That's 32 already. And this is a singleton. Yeah, so that's the reason why that doesn't work. So, we can't have this... One of these, at least, must be part of this region. Is it both? So what happens if we have region here and then region here? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we could actually exit this way, right? We have 1, 2, 3, 4, 5, 6, potentially. That could potentially work. But what does that mean for this as a size? 1, 2, 3, 4, 5, 6, 7, 8, 9. This adds up to 11. And what does this add up to? Well, first of all, we don't have access to a 9. Because 3 digits adding up to 11 can never have a 9 in it. It can't be 1, 2, 9 because that adds up to 12 at minimum. This can't be 9. None of these can be 9. And this can't be 9 because it's 4 at most. So the answer is no. These cannot be a separate region. They have to be part of the same region. Which means one of these is 1 or 2. Which eliminates 1 and 2 as a possibility for this being a 1-2 pair. So this is guaranteed to be 3 and 6. There we go. That means this can't be 3. That's 1. This can't be 1 here. It's 4, which makes that 3. 4 and 3 add up to 7 times 3 is 21. Plus 2 is 23. So no more 3 here. No more 6, 7 as a pair. It's 4, 9 as a pair. This can't be 4. It's 7. So this has to be 1 with 5 or 8 here. That means this is 7, so no 7 here. 3, 6, and 1. That eliminates 3, 6, and 1 in the rest of the box. Or cage. 7 is here. This is either 1, 5, and 7, or 1, 8, and 6. Interesting. So this is 2, this is 4. This cannot be 4, 6. So this has to have 7 or 9. This must have 7 or 9 in it, which eliminates 7 and 9 in the rest of the column. So we can have 1, 3, 5, 6, or 8 here in the remaining digits in column 8 or 7. So this is 4, 9 as a pair, 3, 6 as a pair. This is all part of the same region. So this cannot be 3, 6, or 7. We could have 1, 2, 4, 5, 8, or 9. if we had 2, 3, 4, 5, 6, 7. This could be part of that digit, of that region, so we don't know. We know there's another singleton here. It could technically, can it? So can this be, can whatever singleton's here be not part of this region? I think the answer to that is no. You can go 1, 2, 3, 4, 5, 6, 7, 8, 9. So potentially that's possible. No, that's not touching an edge. So the answer is no. And the reason why, so we can go twice through the 4 cage, possibly. We can go once through the 2 cage, only. But the problem is we can't reach an edge. So if this is green, if both of these are green, they're part of this region. Or potentially another region here as a green. Oh, maybe that could... No. So to form a full 9, so this is green. If this is green and not part of this region, this can only have 8 here, so it would have to continue here. This gets blocked from touching an edge there, so it has to go this way and then can't reach a region. So if there's a green here, it's part of this region. If this, we know one of these is at least 11. So we actually have either 8 digits here adding up to this sum, or all 9 digits here adding up to all of these. Can we have just all 9 here, is the question. So that would be 11 plus 6. So let's use a calculator. 11 plus 6 plus 7 plus 9 is 33. We cannot have that add up to 33 plus 8 is 41, so we could have a singleton going here, potentially. We know 2 of these digits must be part of this region, although they can't extend to anywhere else. So this is 1, and we have to have 1 at least here. If we try to have a full region here, it does not work. So one of these is green, one of these is blue. We can extend either to here or to one of these. So 6 plus 11 plus 7 plus 9 plus 5. That would mean the other singleton digit would have to be a 7, which is not possible. So this must be an 8. So this is 8. These are 2 digits adding up to 11. Without 7, without 8, and 6. That eliminates 3, 8, 4, 7, and 5, 6. So this must be a 2, 9 pair, which eliminates 2 and 2, 4 as a possibility to add up to 6. We have to have a 4 be the remaining digit, so we have to have 2 or 9 be there. We don't know what the other digit is. This is 1, 5 as a pair. And if this were a singleton, so we have 1, 5, 2, 9, we have to have 4 remaining. If this were a singleton and part of the region, it would have to be essentially a 4, which is not in a 1 to 2 ratio with 1 or 5. So this must be a boundary. So that's boundary there. And we have to have a 4, which connects to either here or here. So that means 4 has to be connecting to here. So one of these is a 4, which means none of these, the rest must be blue. So these are all blue. That's 0 to 0 and is a ratio. This can't be red. We know one of these is green. This is a boundary. Well, we don't know if that's a boundary there. So we don't know what that is. Remaining digits in column 1. We have 2, 3, 4, 6, 8, and 9. Those are the possibilities. Interesting. One of these is 4. These are all blue. This can't be doubled. It can't be reached by any of the doubled regions. This can't go through here to get to there. So this is not double. It could potentially still be green. This could be doubled going that way. This could be doubled going that way. So that's possible. Okay. This is 0, so this must be boundary here. Well, this is a doubled anyway, so yes, that's a boundary. This is a boundary. This could still be singleton. If these are double, these are all the same region. This cannot be just a singleton. It's blocked by the zeros and the doubles. So this has to be part of doubles and is part of the light region. So this is all part of the light region. This is in a 1-to-2 ratio. We have 1, 2, 3, 4, 5, 6, 7. We can only go 2 more. So these cannot be read. These are singletons there. This could be going that way. This could be going that way. This is either going to be blue or part of the light region. We don't know. Can this add up to 14? Yes, if it's doubled. So this is either going to be 1, 2, 4 doubled, adding up to 14, or it's 3, 4 doubled, adding up to 14. So we cannot have 6, 8, or 9 here. So we're guaranteed one of these is a 4, which means this cannot be 4 here. This has to be in a 1-to-2 ratio with this, because they're the same region, so no 9 there. Can we actually ever have a 9 here? The answer is no. Oh, 5 eliminates 5 here. So this cannot... This is 8. This can't be 8 here. So we have to have an 8 here. It's 42. 49 minus 7 is 42. Divided by 3 is 14. So this has to be... This can't have an 8. This must have an 8. So it has to be 6 and 8 here. That means this can't be 6. This can't be 6. That's 7. There's no 8 here. It's 1, 5 as a pair. This is 7. No 7 here. That's 5, 9. So 49 is... Minus 7 is 42. Divided by 3 is 14. 50 divided by minus 8 is 42. Again, divided by 3 is 14. 27 minus 6 is 21. Divided by 3 is 7. So that eliminates 7 in the rest of the column. We know the other 2 or 9 is here for the green. Oh, it must connect to one of these. So this must be the other green here. Oh, that's not true. We could connect here and then connect here. Okay, never mind. This is guaranteed to be 4. This can't be 4 here. These are double. So... we have guaranteed 4 here. 9 cannot be doubled here. 9 plus is doubled is already 18. So where is the 9 then? In column 1. It has to be here. So that's 9, which eliminates 9 in the rest of the cage. One of these has to be 6 or 8. 8 doubled and 2 doubled is too large. So this cannot be 8, it's 6. That eliminates 6 in the rest of the column, so this can't be 6, it's 8, which makes that 6. 6 eliminates 6 here, so it's 3 and 6 there. That eliminates 6 in the rest of the light region. Also, we can't have, yeah, 2, 3, 4, 6. This is guaranteed to be 2. 2, 3, 4, 6 doubled is 30. So it's 15 times 2. That's 30, which means this has to be either 1 or 2. It cannot be 2 because of the 2 guaranteed in the column. So this must be 1, which means it's 1 doubled to add up to 32. That's here. And this is not part of the region. So that means this cannot be 4, 8, and 9. It can't have a 6 because of the 6s in the column. So this must be 5, 7, 9, adding up to 21, which is doubled, is 42. We need an 8 somewhere doubled here. It could be here. We don't know. It's one of these two, actually. So this is one of the lights. And this could be green. We don't know about this. So these are all doubled. And it cannot be 1, 2. It has to be 1, 2, and 6, adding up to 9, which is doubled to 18. That eliminates 2 in the rest of the column, so this is 3, 4 as a pair. That is 7 doubled, adding up to 14. So this becomes a 3, 4 pair. We know there's a 4 in one of these. Remaining digits in column 2. We have 1, 2, 3, 6 accounted for. We could have 4, 5, 7, 8, and 9. No 9 here, obviously, because we have 9 in the cage. This can't be 4 because of the 3, 4 pair in the cage. Okay. One eliminates 1 in the rest of the row. So no 1 here. Oh boy, this is pretty crazy. This is boundary here. What else do we have? We have an 8 missing, so one of these two is an 8. We're not sure which. That eliminates 8 in the rest of the column. This could be 0 also, though. So this could be 0 or green. This is 1, 5. We have 2 with 1, 5. Interesting. Hmm. Okay. This is pretty convoluted. Remaining digits in column 3, we have 2, 3, 4, 5, 7, 9. 4 obviously cannot be in this cage because the 4 has to be part of this region here. And these could be 2, 3, 4, 5, 7, 8, 9. Okay. Hmm. Okay. Okay. So we only have two regions that are doubling. Okay. And okay, so this cannot be doubled. Because if this were doubled, we already have the one doubled in this region. So this can't be doubled. But this could still be doubled if it goes that way. Or this way, or something of some sort. We have 1, 2, 3. We have a decent amount here. Um. Hmm. Okay. 3 eliminates 3 in the rest of the column here. Okay. This is 5, 7, or 9. Where is 2 in row 3? It can only be in the 2 cage, interestingly enough. But we could still technically have the 2 be part of a region that shares an edge with 0 cells, or 0 edges. This is guaranteed to have... So we cannot have 5 and 9 here, because if we had 5 and 9 here, that would eliminate all possibilities for this cage here. Because it's either 4, 9 or 5, 8 here. So this cannot be 5 and 9, which means this can't be 7. So one of these is 5 or 9. One of these is 5 or 9. That eliminates 5 and 9 in the rest of the column. So this can't be 9. Also, we have a 7 here, which eliminates 7 in the rest of the column. Or row, sorry. So this is 7. That means this can't be 6 or 8. It's 6 or 8 there. We have 7 or 9 there. Oh boy. Okay. If this were 6 as a... It can't be doubled, because 6 doubled is 12, which is larger than the sum. If this is 6 as a singleton, this is 2 as a doubleton, and that would eliminate all possibilities for that cell. So this cannot be 6 here. Okay. Wow. If this is 1, as it has to be a double, which would force this to be 4 as a double. If this is 2, it would have to be 2 as a double, which would be with 3 as a double there. If this is 4, it could be a single with 3 as a double there to add up to 10. If it's 4 as a double, it could be 1 as a double there. So can this ever be 2? I don't think so, right? 2 doubled is 4. Plus, it would have to be 6, and that would eliminate all possibilities for that cell there. So this cannot be 2 here. That's nice and convoluted. Oh, boy. This is pretty crazy. This could be blue. Can this be blue? If this is blue, blue has to get out there. So then these 2 digits, with 1 being doubled and 1 not being doubled, would have to add up to 36. So this cannot be blue. One of these is 8 doubled. Okay. Okay, yeah. One of these is 8 doubled. The other 3 cells can only be a single. Well, this could no. If we tried to go all the way here to make this a double, the problem is this is not a large enough region, right? We have 1, 2, 3 doubled there. This is 1, 2, 3, 4, 5, 6, 7 only as a singleton, which is not allowed. So this cannot be doubled. The other 3 digits are not doubled. they are single at most. And 36 minus 8 doubled is 16. That's 20. So the other 3 digits must add up to 20. So all the rest must be green. So that means they add up to 20. We don't have an 8 available. So we cannot have 2 there. It's either 4, 7, 9, 5, 6, 9. We can't have 5, 7, 8. So we have to have a 9 somewhere in this cage. Interesting. Okay, so how does this interact? So if this is 8, okay, so if we have 8 here, that's 7. This becomes 4, 9 as a pair, which means 9 can't be here, so 9 has to be there. Or, if this is 9, obviously 9 cannot be anywhere else in row 2, either. So, either way, we cannot have a 9 available in row 2. So these are all must be the same region? Maybe, maybe not. No, this has to be part of the same region. Well, not necessarily. Not necessarily. Not necessarily. Okay. But we know these can't be 9, which means we have to have a 9 in one of these 2 cells, which eliminates 9 in the rest of the row. So this can no longer be 2 here, because 2 and 9 doubled would add up to 22. This can't be 7 anymore, so that eliminates 4 and 7 here, adding up to 11, which doubled is adding up to 22. This is a singleton. As a singleton, why can't this be 7? I don't have, no, oh, this is 7 or 9. This is 7 or 9. Okay. So to add up to the 11, okay, so what are the possibilities? 3 and 8, 7 here, would have to have 4 there, or 2 doubled there, but that doesn't work, so this can't be 7. 5 and 6 works fine. 8 can't be here, because it has to be with a 3 single. And that can't be 3 because one of these 2 is a 3. What about if this is doubled? 3 doubled with 5. Right? So right now we have 3, 8, 5, 6. No 4, 7. Because this can't be... If this can't be 7 with 4 being there, and this can't be 7 because of the 7, 9 pair in the column. And if this could be 3 doubled, you cannot have 5 doubled here. 3 doubled is 6 plus 5 works. So this cannot be 4 here. So this is either 3, 8, 5, 6, 3 doubled with 5 as possibilities. So if this is doubled, the problem with that is all of these have to be doubled because they have to be all part of the same region. And the problem is we already know this adds up to 88. So if this were the last part, it would have to be 1 doubled, which is 2, to add up to 90, which is the digits 1 through 9, 40, which adds up to 45, doubled. So this cannot be doubled. It has to be a single here. So this is 3, 8, or 5, 6. These could still be doubled, though. We don't know. Interesting. So 9's one of those 2. If this were the same region, they would have to be in a 1 to 2 ratio, and 9 is never in a 1 to 2 ratio with another digit. So, you cannot have a 9. This cannot be the same region. So this must be light. This can't be light. This is part of that region here. Well, not necessarily. It's just a singleton at least. So this has to be, that's the full region there. This is 8. That makes this 9 there. 8 eliminates 8 in the rest of the row, so this can't be 8 and 3. It's 5 and 6. That eliminates 5 and 6 in the rest of the row. This can't be 6. It's 2, which makes that 6. This is 9. It cannot be 8. There's no... How did I get a 3 there? I don't even know. It's either 4, 7, 9 or 5, 6, 9. So no 5 there. No 5, 6 because of the 6 in the row. So this is 4, 7 as a pair, which eliminates 4, 7 in the rest of the row. So no 7 here. It's 9 and 6. 9 eliminates 9 here, so it's 5, which eliminates 5 here. So this is 7, 9 as a pair. That eliminates 4, 9 here as a possibility. It's 5, 8 as a pair. That eliminates 5, 8 in the rest of the row, so no 8, no 6 here. 6 and 9 eliminate 1, 9 here. It's 3, 7 as a pair. That eliminates 3. This 6 eliminates 6 here. So that's 5, which makes that 6. 8 eliminates 8 here, so that's 7. But this has to be 2 digits adding up to 11. So we have 9. This is 6. We have 5, 8. 3, 7 here. No 5 or 6. It's 1 and 8 left here. Okay. This, well, it could be another region adding up, so... This cannot, well... Again, these have to be doubling to add up to 22. And this is 3, 4 as a pair. This can't be a 7 as a singleton, so this must be a double, which means it's part of this region here. And then this becomes part of that region there also. So these are all dark. This is a boundary here. So we cannot go 3 this way, so this is not red. But they could be, these are singletons. We need 3 singletons to add up to 19 because 2 singletons can only add up to 17 at most. So we have all of those are green. These are not in a 1 to 2 ratio, no matter what. 6 and 1 and 6 and 8 are not. So this must be a boundary. So this cannot be doubled. These have to be these have to be single at most, and these add up to 9 at most, so all 3 of these must be singles, which means this must be 9. So that eliminates 9 in the rest of... This can't be 5, 9 because of the 9 in the row, so this is 6, 8 as a pair. That eliminates 6, 8, and 9 in the rest of the row, so no 8, no 6, 8. This adds up to 19. They could be part of separate regions, though. These are doubled, so it's either 1, 4 or 2, 3 here. This is 3 or 4 here. And this adds up to 20. Sorry, this adds up to 88. We already calculated that before. So the last remaining digit in this part of this region is 1, which is 1 doubled. So this must be then 2, 3. This is 4. That makes this 3. No 4, 5, 6, 7 here. That leaves 1 and 8 remaining in the rest of the row. And this can only be 1. These can't be... One of these could be doubled. But if we have that doubled, remaining digits in... So this can't be 5, 6, 7, 8, and 9. This can't be 2 or 3. It's 1 or 4. We already have a 1, 8 pair in this cage. This can't be 1, so that's 4. And to add up to 13, this must be singletons. Because none of them... the only double that can be is 1. So we have 3 and 4 here. That eliminates 3, 4 in the rest of the column. This has to be a boundary because it's not in a 1 to 2 ratio with either. This cannot be 1 doubled, so we can't reach there. So therefore, this one of these must be 1 doubled. That makes this a 1, 2 pair. 1 doubled plus is 2, plus 2 is 4. So one of these is doubled, the other one is a singleton. That eliminates 1 and 2 in the rest of the row. So this can't be 1 or 2, this can't be 4, this can't be 6, because the 4 is 6 in the column. 4 eliminates 4 here, so that's 3, which makes this 4. 1, 2 eliminates 1 here, so that's 8, which makes this 1. 2 eliminates 2 here, so that's 1 and 2 here. So the 1 doubled has to be here. So this is the dark region. This is not dark. So that's boundary then. So we know all of that's boundary. This is 2. 1 eliminates 1 here, so it's 5 and 1. 5 eliminates 5 here, so it's 8 and 5. 8 eliminates 8 here, so it's 6 and 8. Remaining digits in column 9 are 6 and 9. This can't be 9 because of 9 in the row, so this is 6. That's 9. That's not in a 1 to 2 ratio, so this is a boundary. Remaining digit in column 8 is a 4. That means this can't be 4 and it can't be 9. So this can't be 4 anymore, which means this is not part of this cage, which adds up to 4. So this doesn't touch an edge. Therefore, this must be 4 here. So this is part of that region. Oops. It's not green. It's part of that region there. 1 eliminates 1 here, so that's 5, which makes that 1. 4 eliminates 4. There's no more 4 available here because of 4 in the column. 5 eliminates 5 in the column. We have 2 here. Okay. No 5 here, no 9 here because of 5 and 9 in the row. This can't be 8. None of these can be doubled anymore. So 2 has to be one of these 2 here. This is a 1-2 pair. All of these must be green. We have 4 here. That eliminates 4 here. So this is 9, which makes that 4. That eliminates 4 in the rest of the column. No 9 here. These can't be doubled, so they have to add up to 12 as singletons. So this is 5, 7 as a pair. That eliminates 5 and 7 in the rest of the row, so this can't be 5 or 7. No 7 there. 8 eliminates 8 here, so this is 9, which makes that not 9, that's 3. That leaves that as a 6. 3 eliminates 3 in the rest of the column. 9 eliminates 9 in the rest of the column, so this is 7, which makes that 9. 7 eliminates 7 here, so that's 2, which means this can't be 2 or 7, it's 8. So the 2 here to add up to 11 must be here. This can't be 2, it's 8. So we have region this way. No 2 or 9 here because of 2 or 9 in the row. Okay, 3 eliminates 3 in the rest of the column. Six is not part of a region. It's part of a 0 region. So is that. One of these is 2. We don't know which. This can't be 6 because of 6 in the row. Remaining digits of row 5. We have 2, 3, 7, 8. No 3 here because of 3 in the column. This could be 3 here. No 2 here because of 2 in the column. Okay. Oof. 8 eliminates 8 here in the column. One 8. 3 here eliminates 3 in the rest of the cage. So this becomes a 2-7 pair, which eliminates 2-7 in the rest of the row and cage. This can't be 2 or 7. It's 8. This can't be 3 or 8. sorry, 7 or 8, it's 3, which means this must be the digit that's part of a region. So this cannot be. So no 3 there. This is boundary here. Boundary there. So since this is boundary, we don't care if it's a 1 to 2 ratio. Where is 2 in column 3? Can't be here because of 2 in the row. Can't be here because of the 2, 7 pair in the cage. Can't be here because of 2 in the row. So it has to be here. So this is 2, that's 7, which eliminates 7 there. So it's 4 and 7 there. That 6 eliminates 6 here, so it's 5. This can't be 5 or 7. It's 4. Okay. 9 eliminates 9 here, so it's 5 and 9. 8 eliminates 8 here, so it's 1 and 8. 1 eliminates 1 here, so it's 2, which makes this 1. The 2 must be counted a single time, so and therefore this is not in column. 1 to 2 is a 1 to 2 ratio, so that's fine. The 4... Okay. Remaining digits of column 4, we can't have a 2 here because of 2 in the row, so this must be 2, and this must be 3. 3 eliminates 3 in the rest of the row, so this is 7, that's 3. That eliminates 7 here. This is a 1-5 pair. Remaining digits. 1 eliminates 1 here, so that's 5, which makes this 1. 5 eliminates 5 here, so it's 7 and 5. And the remaining digits are 6, and this is going to be a 7. Okay, so then we need to divide these into regions. How do we do that? Okay. This one cannot be part of this cell here. These are 2 separate regions because they are not in a 1 to 2 ratio. So this is part of that region there, obviously. And this one cannot be part of the one there, so that's a full region there. We have 2, 6, 9, 1, 3, 8. We need access to a 4, so that's a 4. So then this becomes a region there. How do these regions work? This 4 is part of a different region than this. So yeah, I don't think this is an either. This has to be either or. It cannot be both. 8 is obviously part of the region with 5 here. So that means this 8 and this 5 is a part of a region. So 5 and 8 here are part of a region. 5 and 8 have to be part of a region, which means this 8 and 5 includes the 6. It must include, so 8 and 5 includes the 6, 7. So these are all part of the region. We cannot access the 7 here, so that's going to be blocked. That means we're not going to be able to access that 2, so we need the 2, we need the 3 then. And those are the regions. So this is 7. Woo! That was a doozy. That was very difficult. Definitely very hard. Satisfying, but very hard. Yeah, that was a doozy of a puzzle. Lots of things you had to figure out. And they were not easy to figure out either. Lots of geometry, lots of adding things together, lots of adding and I don't even know if that's not a word. Geometrizing of the puzzle to try to figure out what can be where, right? But that was very satisfying though. Very satisfying. Anyways, I hope you enjoyed that solve, and I'll see you next time on Frank Puzzles. Take care.